this is sort of a technical session, and it's a different domain, it's a different talk that you'll all be excited about. It's a new topic that you'll all be learning about. Cool. So the topic of today's presentation that I'm giving is Scaniverse and unified scanning in Linux systems. By the way, I am Akarshan Kapoor. I have just recently graduated from IIT Mandi, Indian Institute of Technology, Mandi, and it's been around 1 month since I have graduated. Still waiting for my actual convocation ceremony, but here I am presenting. A bit nervous, but let's get started. Cool. Okay, so I mentioned about Scaniverse, right? Is the pointer on? Cool. This talk that this software that I have been making has sort of been evolving around as the number of talks that I give. So I wanted to quickly share the history, because in software history is very important. Version history is generally very important. So here git log --1 line --, verbose. So it's a bit of a verbose history for you. The version 1 of this talk was originally submitted when I was still doing my Google Summer of Code program. If you don't know about that, that's an awesome program that you have. It's for new contributors to come in and start coding, contributing to open source. So if you haven't heard about me, contact me later and I'll help you get started. Cool. So this was for my first Google Summer of Code program that I had. And the version 1 that I had at that time was basically reading about PAPPL and implementing sort of printer applications in PAPPL itself. There are a lot of buzzwords in this verbose history, but don't worry, I'll quickly guide you through the entire presentation that I'm presenting. Cool. The version 2 here is basically, I gave it at FOSDEM. FOSDEM was held in Belgium, Brussels. So that's when I started integrating some of the more deeper intricacies of the software. I'll help you later on the technology as well. But apart from that, the third version is the major version here that I'm presenting today at UbuCon Asia 2025. And I hope you all will at least get some insight about scanning and printing on Linux systems. Cool. So, before we get started, what's this software actually about? PAPPL, Printer Application Framework. And what happens when you actually are new to a particular command or something, you just go ahead and check out the man command. So man PAPPL, so basically it's a C-based framework. It's a simple library. It's basically written in C. It's a simple library that is usually developed for, it's used for developing CUPS printer application frameworks. It is a recommended replacement for traditional printer drivers. What exactly it is, it's kind of a server. So basically you must have heard about a client server sort of interaction between a client and a server. So it's a server that a client can connect to, and yes, you will be able to go ahead and configure your own printing and scanning. Here printer and scanners are basically those devices that you print or scan upon, right? So you can go ahead, connect to this, and yes, boom, you have a working printing and scanning system. It's multi-platform. It works with desktops, embedded environments, and it's easily adaptable. One thing that I like to mention right now is, since we are at UbuCon here, we all have been familiar with different operating systems like Ubuntu, right? But the major framework that I like to focus upon is actually that it's also on embedded environments. So what do I mean by embedded environments here? It's basically referring to real-time operating systems, RTOS. So RTOS is something that PAPPL can also run upon. Cool. So next slide. We understood like a broad overview of the entire thing, like what PAPPL is, what it does. But how about we explore the more deeper intricacies about the API, how the API calls actually work. So as you can see on the left hand side here, we have a block diagram. This is a simple UML diagram for you. So at the very top, we have something called as a system class. And then we also have something called clients, devices, printers, and jobs. Cool. So the system is basically the main object that manages the entire printing system for when you're developing a new printer application. Then we have sort of clients, devices, and printers that are inheriting from the system class, and the client is basically respectively for managing the client connections, the devices for managing the printer connection, basically the devices, and the printers for actually managing the hardware connections on the local printer that you have. And we also have the jobs. So obviously if you're printing, you'll have print jobs, you start queuing, you'll be printing a lot of different documents. So we have all of this nested in the PAPPL block diagram. Also, what I would like to mention here is that the PAPPL block diagram also contains the resources, listeners, and the log. So everything that you do, every printing job that you execute, every scanning job that you execute, scanning is not currently implemented. I'll be talking about it later. But everything that you actually execute, it's there. It's actually stored within the system, locally within your system, and that's why PAPPL is so cool. So we had a look at API, we had a look at all the different things, like what is a broad overview about PAPPL, but how about, let's suppose you guys want to go ahead and get started by installing PAPPL. So there's this one-liner command that you actually do. Obviously you'll have to clone the repository first. Once you clone the repository, this is for printing, by the way, you go ahead /configure make and sudo make install. That's it, as simple as that. Just a one-line command, and then boom, you have everything working. So what we actually wanted to do here was basically have a minimal effort and a maximum efficiency system. So in that sense, basically it's a plug and play system that you can go ahead, connect to your laptop, clone the repository, and boom, you'll have everything working. Next, what you'll have to do is, let's suppose you have a printer and you have a configuration for a driver on your own. What you'll have to do is only write the callback function, the necessary callback function. All the external details like handling the jobs, queuing with the client, all those things are actually handled within PAPPL itself. So it's like we're providing you a very extracted overview. You'll only have to write the callback functions. Next, PAPPL handles all the heavy lifting, as I told, and it is complete, and it's built in with the IPP support, Internet Printing Protocol. So it's built with IPP everywhere, and it ensures that we have seamless compatibility. Cool. But I have been talking quite a lot about printing. How does scanning come into the picture? Well, it all starts with sane going insane. Now, what do I mean by that? Sane is actually the de facto standard that Linux uses for scanning systems. It actually stands for Scanner Access Now Easy. So that's a very nice acronym that they have come up with. What sane works, I'll guide you how to, basically how sane works. Basically, you'll have a front-end application, let's suppose Simple Scan or Xsane. That's a front-end application that shows the scanners that are being connected to. And the back-end, you'll have dynamically loadable driver systems on the back-end. So both of these can be coupled together, and each back-end runs and reports which scanners are currently available. So a front-end, a back-end, and boom, you have a complete application. So this is how technically sane works. But the problem with this is that for sandboxed applications, for each of the drivers that you write, wait, let me put it more clearly in a more simpler sense. Let's suppose you have Y numbers of different scanners. For each of those older scanners that you have, you'll have to write the driver code. Once you have written the driver code, you will be porting that to a backend application. So how many backend applications do you have? Y. And let's suppose some people anywhere in the world, they go ahead and develop X number of different front-end applications. So if we do general math, apply permutations and combinations here, we'll get X into Y total number of softwares out there. So is this feasible? Like, no, right? So we'll go ahead and implement some sort of a sandboxed application framework which is within PAPPL itself. Cool. So those are the problems that I actually mentioned right now. And moving on to the next slide. Okay, so we mentioned about the problems with sane, right? How do we go about actually implementing the solution behind it? Well, has someone already written it? I'll disclose this afterwards as well. So has someone already written it? Yes, short answer yes. The solution here is that we'll have to define each protocol step by step. Very first, how does the protocol communication work? Well, it starts with something called as ESCL. ESCL is something like IPP, HTTP, if you have some idea about that. But apart from that, ESCL is sort of a protocol that allows you to connect for driverless scanning. Next, the scanner drivers that we have should be individually and basically sandboxed in different operating systems. Not only Ubuntu, in general, on Linux as a whole, we should be able to distribute scanner drivers as a packaged application. So, and apart from that, since we already have PAPPL for printing, how about we combine that with scanning? So we'll not be having only printing, but also scanning combined in one for every operating system out there. So that's really cool. Next, we'll replace sane with sandboxing ready ESCL, as I just told. Okay, now we are diving into how we are going to mix scanning into printing within the PAPPL framework. So the first thing is the PAPPL API overview. As I showed you before in the UML diagram, we have something like system, clients, devices, printers, and jobs. So we'll have to develop a new structure called scanners that takes part and understands how scanning works. Next, we'll also have to intercouple the clients, the devices, and the scanners. So right now, the coupling is currently between client, devices, and printers. If we are going to introduce scanning into this, we'll have to configure scanners with devices and clients within the PAPPL API itself. Cool. That's the challenge. The solution, we are actually developing a scanning API within PAPPL and building it on existing principles. But do we actually think about it from the scratch? Do we actually go ahead and configure all the protocols that we have from scratch? Is that even possible? No, that's where the solution, that's what I mentioned. Has anyone written a solution from that? Yes, there's an open source organization. I'm not sure about whether it's open source or not, but there's an organization called Emopriya. They have published something called as scan specifications, and those scan specifications actually detail, basically how scanning should work with scanners and with Linux in detail. So they mention about the RESTful API interfaces. They mention about something called as basically queuing of protocols, queuing of servers. They mention all these protocols out there. And they also mention how we can integrate this into embedded web servers. So that's really important. Next thing, the protocol also defines something as network scanner discovery. Obviously, you will not want to connect your scanner via USB or different things. You'll want it to be available via network as well. So how do we do that? Well, we do that via network scanner discovery. The protocol that has been defined within Emopriya uses the Bonjour protocol. It is multicast DNS, domain name service, and DNS SG for scanner detection. Within that, if you want to go ahead and study more about it, these are a little bit of technical terms, so you'll need a little bit of knowledge here and there about Linux. But UScan TCP and UScan's TCP. So those are the two protocols that are defined under the hood. Cool. The scan job management, how the scan jobs are getting created, how different scan jobs are getting embedded, how are they getting queued. All these are actually also defined within the scan specifications. Also, I mentioned the capabilities here. The capabilities basically are discrete, basically range resolutions, like what scanning resolution do you want from your scanner, like RGB, grayscale, all those things that you can think about when you're scanning from a different scanner. Cool. So we learnt about implementing scanning as well within PAPPL. How do you run this? Like, I'll not always, like everyone out here will not always have a scanner, right? Someone needs to think about and also think, okay, can I run this like, with a test script or something, a debugging script, for example. So we have also created something called as a dummy driver. The dummy driver here is basically something that the scanner actually provides you in real time. So scanner will actually exchange information with the server, right? So within that information exchange within the server, what will happen is that we send text of information. So how about we, clone that sort of information and already keep it within a text file. So if that's possible, then we'll easily be able to go ahead and simulate, the scanner hardware with a simple text file. All that we need to do is, within the callback scanner, we'll have to create a sort of a parser, a text file or an XML file. You'll have to create a parser. That particular parser should be able to go ahead and extract all the information that you have from the, the dummy file that you created, and then be able to store it within the actual data structures that you have defined in the PAPPL algorithm. And if that works, well, all good. You have a successful execution. And basically, you are able to go ahead and check whether it should actually work with the scanner as well. So that's it. Cool. Now, one more thing. I was talking about scanning, but within scanning, there also are some legacy scanners available. Like, not every scanner is like supporting driverless scanning. So what about those that actually support, by the way, this is actually a thing that you can execute in the terminal and you'll have a dancing parrot. So basically you run system CTL enable PAPPL retrofit. PAPPL retrofit is basically the repository that allows you to configure retro scanners, the scanners which do not support driverless scanning. So we also have a repository for that, that actually enables you to go ahead, connect with PAPPL retrofit, and then you'll be easily be able to transform all the retrofit scanners that you have and embed them within PAPPL. This PAPPL retrofit was initially also meant, since this entire software is sort of meant for printing systems, this was also meant for those printers, as I have written on the slide here, those printer drivers which were actually retrofit. But what about scanners in real time? So we are integrating that, and that has also been integrated into PAPPL retrofit. I mentioned if you looked at the talk title, it was like Scaniverse. There's a verse like a universe, multiverse, something like that. Right? The Marvel universe, I'm a big fan. So we have the birth of a universe. How do we integrate that? So we removed bunch of driver code, check. We did remove, we made a working backend coupled with a working front end. and sort of coupled it together into a different application, that is also a check. Legacy SANA support, that is also a check. But what are we missing? Like, we did everything on the terminal. What about a user who is new to Linux, or he's not very pro in scanning or printing? So we go ahead and create something called as Metascan. I'm not sure, I was talking with this person called Alex. He mentioned, I'm not sure he's in the audience right now, but during a hallway session he mentioned that he was using a Sane as a default and using the GUI, basically the graphical user interface. That was a bit difficult for him because he was not able to track everything that he was scanning on his scanner. So what we are here doing, we are not only storing all the users and the capabilities out there, but since we are into the world of machine learning, AI and all those stuff, how about we also store some metadata linked with your document? So let's suppose you have a passport. You have a passport, you scan your passport, but a passport is like a very generic example, but let's suppose you have a test paper somewhere and you want to scan that. You scan that test paper, and within the contents of that document, you have something embedded, but you're not remembering the name of the document you basically put during saving a file. So what this particular front end will do is it simplifies document retrieval as a whole. How? Let's talk about that. So this is probably the last slide. I hope I'm not boring you. So please bear with me. This how basically Metascan works. So in short, what's happening behind the scene is you have a front end. What happens? You scan a particular document. There you go. You scan the document using any particular open source software that you have, open source like PAPPL as well, or existing solutions as well. So it's basically totally plug and play. At the end, what you do is do OCR processing. Now some people will go ahead and ask, okay, Akarshan, why not go ahead and introduce VLM? Like visual language models that actually go ahead and extract information out of the image already. Well, that is also possible, but we are thinking of something that is running on the edge, that is very resource constrained. So we go with the simple PyTesseract library that goes ahead and introduces the Tesseract OCR engine. The OCR extraction, basically the natural language processing, we use some techniques called as named entity recognition, or basically all the things that are actually stored in natural language processing. Through libraries, we extract all the information out there, and once we have that, we archive that to a SQLite database, so local as well. So data access is via a backend server. You have a Flask-based server. This is currently being upgraded upon. We're thinking of better options. But the SQLite database that we have is basically where you store all the metadata information. Next, we also have the user interaction via the front end, simple front end. So, I did not have time, so I configured it in HTML, CSS, and JavaScript. Nothing fancy like React or Tailwind. Nothing like that. Simple HTML, CSS, JavaScript. There's basically you have to keep the GUI very simple. Cool. The document retrieval, as I mentioned, there's an algorithm behind that. I don't think I have the time right now to talk about that, but definitely ping me and I'll be able to tell you later about how the algorithm works for document extraction. The last one is you have digitized documents. So what did we have? Like, if you wanted a simple overview of what this talk is going to provide to you, we developed a backend CLI that couples printing and scanning for any operating system out there. We developed we developed a front end for it. That's also cool. We coupled them together and created sort of a scanning universe. So printing and scanning, I hope you all have some information. I hope I made the information really good for you, and you'll be able to utilize it in the future. Thank you. That's it from my side. I'm happy to connect. This is my LinkedIn. Scan it, and if you have any questions, let me know. Thank you. Thanks a lot. Yeah. Why using Flask? Well, that's a very good question. The primary focus, as I said, was getting the backend, the ESCL framework and all those getting ready. The front end is basically, improving upon how the user interaction is. Currently, it's not very thought upon. So maybe in the future, we'll go ahead and implement a different technology. But now Flask was the easiest to configure. Python, Pythonic backend, easiest to configure with Flask. That's how it's built on. The front end is basically plain HTML, CSS. Yes. That definitely contact me. This part, the part before basically the front end, is still being thought upon. It's very new, so we are giving a thought about it, how to progress further. Ideas are welcome. Sorry, could you repeat again? Correct. So basically what we are doing is connecting a Flask server to the Pythonic, basically to the SQLite library. And those are connected, the front end is coupled with HTML, CSS and JavaScript. I hope that answers. If you're not like, I could not understand your question very well, but if you have any doubts, contact me later and I'll be able to help you out. Any more questions? Great. Thank you. Thank you so much. Have a nice day. Have a nice evening.